Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are fine. I am Mrs. Amina Sadiq, working as subject specialist in mathematics at Divisional Public School and College, Sahiwal. My dear students, today we are going to discuss about direct and inverse variation. This is lecture number 23 and we are going to solve exercise 3.2. In this lecture, we are going to discuss about direct variation, inverse variation and exercise 3.2 question number 1 to 13. So, what is a variation? In problems relating to two variables, it is seen that the value of a variable changes with change in the related value of variable. Such relationship is termed as variation. Like if one quantity increases, the other increase. If one decrease, the other decrease. If one increase, the other quantity decrease. Such relationship is called variation. In this lecture, we are going to discuss about two types of variations, direct variation and inverse variation. So what is direct variation? When we discuss about the direct variation, it means a variable changes proportionally. Changes proportionally means if one increases, the other increase. If one decrease, the other decrease. Or we can say that they increase or decrease together. Such relation is called direct variation. If we say if y is in direct variation with x, it can be symbolically written as y is directly proportional to x, or we can say that y varies directly with x. This symbol is called the sign of proportionality. Direct variation describes a simple relationship between two variables. Y varies directly with x if y is directly proportional to x. We can remove the sign of proportionality and replace it by a constant term called k. This expression will convert into y is equal to kx. This k is a proportionality constant, so it should not be equal to 0. We can find the value of k by changing this equation to the form k is equal to y over x. This k is called the constant of variation or the constant of proportionality. This means x increases, y increases, and as x decreases, y decreases, and that the ratio between them always stays the same. The graph of the direct variation equation is a straight line through the origin. As we can say that if A varies directly with B, their graph should be like a straight line that passes through the origin. We can also understand this graph by age and time. Age varies directly with time. When we are a kid, our age is less. When the time passes, we start growing up. And as the time passes on, we become an adult. and this goes on. Let's have another example that explains the direct variation. We have two circles. The first circle has the diameter 1 unit and the second has diameter 2 units. The diameter and the circumference of the circle are in direct variation. It means when diameter increases, the circumference increases. When the diameter decreases, the circumference also decreases. In this case, we are taking diameter as 1 unit. So, the circumference is equal to pi, which is equal to 3.14159265, so on. And when we are considering this circle has diameter 2 units. So, the circumference is equal to pi d, which means 2 times pi. Or we can write it as 2 times 3.14159265, so on. As the diameter increases, the circumference of the circle increases. And when we consider a smaller diameter, the circumference will also be reduced. So we can say that in a circle, the circumference of the circle increases or decreases in the same proportion with the diameter. So they varies directly. So we can define direct variation as if two quantities are related in such a way that increase or decrease in one quantity causes increase or decrease in the other quantity, then this variation is called direct variation. Or we can write it as y is equal to kx. Now, let's solve the problems related to direct variation. We have a question: if y varies directly as x and y is equal to 8 when x is equal to 2, find. It means y and x have a direct relation, or they are in direct proportion, or we can say that y is directly proportional to x. The value of y is 8 and the value of x is equal to 2. Then we have to find. The first part is we have to find the value of y in terms of x. For this, first of all, we remove the sign of proportionality into the constant of proportionality and equality. So y is equal to kx. Putting the value of y and x, we get k is equal to 4. Now we put k is equal to 4 and y is equal to kx, we get y is equal to 4x. So this is the equation in which y is expressed in terms of x. Now for the second part, we have y when x is equal to 5. We know that y is equal to kx. Putting the value of k and x, that is 4 and 5 respectively, we get y is equal to 20. Now for the third part, we have to find the value of x when y is equal to 28. We know that y is equal to kx. Putting the value of y, that is 28, putting the value of k, that is 4. When we divide 28 by 4, we get the value of x, that is 7. Now we have fourth question. If r is directly proportional to t square and r is equal to 8 when t is equal to 3, it means we have to find the value of k by using these two values. Then we have to find the value of r when t is equal to 6. For this, we know that r is directly proportional to t square. If we remove the sign of proportionality into the constant of proportionality, that is r is equal to kt square. When r is equal to 8 and t is equal to 3, this equation will be equal to 8 is equal to k times 3 square. 3 square equals 9, and when we divide 8 by this 9, we get the value of k, that is 8 over 9. When we put this k equal to 8 over 9 and t is equal to 6, in this equation r is equal to kt square, we get r is equal to 8 over 9 times 6 square. 6 square equals 36. After cancellation and simplification, we get the value of r, that is 32. In the next question, we have if w varies directly as u cube and the value of w is 81 when u is equal to 3, it means these two values will give us the value of k, the proportionality constant. After this, we have to find the value of w when u is equal to 5. For this, we know that w is directly proportional to u cube. Replacing this sign of proportionality with the constant of proportionality, that is k, we have w is equal to k times u cube. When w is equal to 81 and u is equal to 3, we get 81 is equal to k times 3 cube, or we can write it as 81 is equal to k times 27. Now for the value of k, dividing 81 by 27, this equals 3. So we put the value of k equal to 3 and u equal to 5. In this equation, w is equal to k u cube. We get w is equal to 3 times 5 cube. 5 cube is equal to 125. So we get 3 times 125 equal to w is equal to 375. Now we have inverse variation. In the inverse variation, if two quantities are related in such a way that increase in one quantity decreases the other quantity, then this variation is called inverse variation. If we have two variables, x and y, we can say y varies inversely as x, or we can write it as y is inversely proportional to x. Mathematically, this can be expressed as y is inversely proportional to x. This 1 over x is the inverse of x, so we can say that y is inversely proportional to x. Removing this sign of proportionality and replacing it with the constant of proportionality, we get y is equal to k over x, and this k should not be equal to 0, or we can write it as k is equal to xy. The graph for the inverse variation never passed through the origin. As we are talking about inverse variation, it has a number of applications in our daily life, especially related to physical objects. Like when we are traveling to some particular location, our speed increases, the time takes to arrive at that location decreases. It means the relation between speed and time is inverse. So, speed and time are inversely proportional quantities. Similarly, when we are discussing about the wavelength and the frequency of some objects, we know that as the wavelength increases, the frequency decreases, and as the wavelength decreases, the frequency increases. So, wavelength and frequency are inversely proportional to each other, or we can say that they are in inverse variation. Let's solve some questions related to inverse variation. Here we have, if y is inversely proportional to x and the value of y is equal to 4 when x is equal to 3, this means we can find the value of k by using these two values. Then we have to find value of x when y is equal to 24. So, as y is inversely proportional to x, we replace the proportionality constant with k. We get y is equal to k over x. When y is equal to 4 and x is equal to 3, 4 is equal to k over 3. So, we have the value of k, that is 12. Now, for the value of x, we put this k equal to 12 and y equal to 24 in the equation y is equal to k over x. After putting these two values, we get 24 is equal to 12 over x, or we can write it as x is equal to 12 over 24, which means x is equal to 1 over 2. There is another question. If m varies inversely with the cube of n and the value of m is equal to 2 when n is equal to 4, which means that these two values will help us in finding the value of proportionality constant, then we have to find m when n is equal to 6 and we have to find n when m is equal to 432. For this, we know that m varies inversely with n cube. So m is equal to k over n cube, replacing the proportionality constant in place of sign of proportionality. When m is equal to 2 and n is equal to 4, we get the value of k, that is 128. So we can say that m is equal to 128 over n cube. When k is equal to 128 and n is equal to 6, we can find the value of m, that is m is equal to 128 over 6 cube, which is equal to 128 over 216, which on simplification will be equal to 16 over 27. Now we have to find the value of n when k is equal to 128 and m is equal to 432. Putting the values of k and m in, m is equal to k over n cube. We can find the value of n cube. N cube will be equal to 128 over 432. On simplification, this is equal to 8 over 27. Taking the cube root on both sides, we get the value of n, that is 2 over 3. My dear students, today we have discussed about the direct and inverse variation. We can compare both as in direct variation, y varies directly as x, but in inverse variation, y varies inversely as x. Direct variation can also be expressed as y is directly proportional to x, or inverse variation can be expressed as y is inversely proportional to x. The mathematical form to write the direct variation is y is directly proportional to x. And the mathematical form to write inverse variation is y varies inversely with x, or y is inversely proportional to 1 over x. When we replace the sign of proportionality in direct variation, we get y is equal to kx for some constant k not equal to 0. And when we replace this proportionality constant in inverse variation, we get y is equal to k over x for a constant k which is not equal to 0. The graph of the direct variation quantities always passes through the origin, and it is always a straight line. But the graph of inverse variation never passes through the origin, and it may not be a straight line. So my dear students, there is your homework. You have to complete the remaining questions of exercise 3.2 and also solve the related examples. My dear students, this is all from our today's lecture. I hope you enjoyed this topic. I have a quote for you related to this topic. My happiness grows in direct proportion to my acceptance and in inverse proportion to my expectations. Stay safe, stay calm, stay at home. Thank you and Allah Hafiz.